Well, good morning. It's good to see you all here. My name is Cora Iberkleid. I'm a developer advocate. Thanks for showing up at 9 a.m. I appreciate it. Hello. So this talk is what's new in Spring Authorization Server 1.3. This representing work from Steve Riesenberg and Joe Granja from the Spring committers team. Unfortunately, they're not here, but they had a lot of input, obviously, into this talk. So I want to represent their work as well. So I guess, how many of you are already using Spring Authorization Server? A couple people. Okay. How many of you are working with OAuth directly in your enterprise, just not Spring Authorization Server? A few people. Okay. And how many of you are finding that you need to set up tests against a Spring authorization, against an authorization server like Keycloak or Okta or something like that? Okay, perfect. Okay. So I'm going to cover a brief introduction just to make sure that we're all on the same page. And then I'm going to go into, the name of the talk is what's new in Spring Authorization Server 1.3. So that specifically maps to two features that I'm going to talk about. One is issuer multi-tenancy, and the other one is token exchange. And then I'm just going to give you a look at a commercial solution that's based on Spring Authorization Server that's called the Tanzu Local Authorization Server. So as an introduction, of course, when we're talking about OAuth in general, we tend to be talking about the space of authentication and authorization, right? And authentication is just logging in with your credentials so that an application can verify who you are, right? So that's, and you've seen plenty of examples online where you go to one website and it asks if you want to log in through another service, right? Whether it's Google or Apple or Facebook or whatever it is, you can see that there is an integration. There's a possible integration for identifying who you are via a third party, right? And then when we're talking about authorization, we're talking about what resources can this application access on your behalf. And I think the most relatable example for that is when you're on your phone, for example, maybe you want to share a photo with some friends on a chat app. The chat app, at the moment that you want to share a photo, it will ask you, can I access your photos, right? So it's the chat application saying, can I access this other resource that belongs to you on your behalf, right? And it could ask you that up front when you install the chat application. It could ask you, can I access your photos? Can I access your contacts? Or it could ask you on an as-needed basis, right? Maybe particular photos or all photos, some contacts. So, but that is the concept of authorization. And there's this, so built into that is the idea that you as a user are granting an application rights to your resources, right? So that's why it asks you. So from an OAuth point of view, OAuth 2 is purpose-built for authorization. It doesn't by itself include authentication. So OpenID Connect adds a layer of identity on top of OAuth 2. And that's why with the two of them, we get a full solution for authorization and authentication. So for authorization, the server part that's handling the OIDC authentication is called an identity provider. And it issues ID tokens that make claims about who you are. So when you log in and Google says, can I share your profile information? It's because it's trying to share who you are, your email, your name, et cetera, with the client that has outsourced, for example, to Google, the ability to have you authenticate through them, right? Whereas for authorization, the tokens that are granted are access tokens based on the permissions that you've agreed to. You want to share your photos? Do you want to share your contacts? Do you want to share, et cetera, right? So those are the two. Now, again, authentication is easier to delegate to a third party. And then the service who's delegated just matches that profile information to your account. But for authorization, an authorization server can only negotiate grants for the resources that it protects. So if you wanted to delegate, for example, if you go to, like, let's say GitHub, right? And you create a GitHub client application, you can use that for login. But you can't really use that for authorization for your internal applications because GitHub can only negotiate like repo read or repo write or resources that it manages. It can't negotiate for the scopes that are relevant to your internal applications. So the question is, how do you solve that problem? And that's where Spring Authorization Server can help. So it provides a lightweight solution that you can seamlessly integrate with the rest of your Spring ecosystem. It doesn't only work with Spring, but it seamlessly with your Spring ecosystem, where you can handle the resource protection for the scopes that are relevant to your applications. And it also can act as an identity provider. So you can get both functions out of it. So just to cover really quickly the authorization flow. So let's assume that your request has already been authenticated. You've already logged in. So just going to authorization, the browser would make so the three pieces on the right, the auth server, the auth client, and the resource server, those three pieces work together. Obviously, the authorization server is the top one, but in the Spring ecosystem, for these, if you have these Spring Boot applications, you'll have a different library for each of them, right? Auth server is a Spring Boot app with the auth server library. Your client is a Spring Boot application. It makes sense sometimes to make that a gateway application, but with the OAuth 2 client library in it. And then the resource servers, the resources are the APIs, right? Your applications, and in those you would add the resource server OAuth library, and then the three of these components can talk to each other and work with the tokens. So if you're already authenticated, a user's browser, for example, would send an unauthorized request, and the auth client would say, okay, I can see you're authenticated, but you don't have the right authorities yet. So you need to go talk to the auth server. So the auth client will send a redirect URL back to the browser, and then the browser will talk directly to the auth server. At that point, the auth server does that negotiation, right? Do you grant access to your photos? Do you grant access to your contacts? And it saves that information, and then it gives the browser a code, an authentication code. It won't pass the tokens directly to the browser. Those will never leave the communications outside of the three Spring Boot apps that are part of this infrastructure. It just gives a code back to the browser. So now the browser can go back to the auth client and say, okay, now I have a code. Let's try again. And so then the auth client can take that code and go to the auth server and say, I got this code. Do you have the tokens for this? And the auth server says, yes, here is the token. In this case, a JOT token with all of the right information in it about who the user is and about the permissions that they've granted. And then the auth client can take that and go try to access the API. Of course, it has to go through that resource server library first, which grabs that token and says, okay, I got a token for you, but let me make sure that it's valid. So it goes to the auth server and says, I got this token. It verifies that it's meant for that resource, for that API by these JOTs have an audience in it, and that audience has to match who it's for. So it says, is this for me? And is this valid? So it can do that by either going to the auth server every time, or if it's a JOT, often it'll just download the public keys from the auth server. And so after the first time, the validation that it's a legitimate token is just done locally at the resource server level. So, and then it can forward the request to the API, and then you get the response, and you can go back, and you have an opportunity through the auth client to also apply. You can say like, well, I don't want to return data if it wasn't meant for this user. So even on the request, you can still use the security features to act on the response. So that's the basic flow. So if you're working with OAuth 2 architecture with Spring, this might be something that you have set up. The auth server has a database where it stores the registered clients, because you can't take any client and talk to any auth server. They go together, right? They have to know about each other, and that information has to be pre-registered in the application properties of both the auth server and the auth client. They have to know who each other is, right? There's a lot of these back and forth checks. So that client registration information is stored in the auth server. A copy of that is at the client. And then any kind of consents or tokens that are issued are also stored. And you can also use the auth server. One of the great things about it is that it gives you this layer of abstraction. You're not restricted to only use the auth server as an IDP or an auth server, but you can use it as a layer of abstraction to then redirect to another one within your organization or an external one. So it's a good layer of abstraction. So with that intro, we'll go into the first issue, which is issuer multi-tenancy. So part of and you can raise your hand at any time if you have questions. So there's part of the OIDC spec states that if there is, like if you see in the second gray block here, if there is the issuer identifier, if it's part of the path, then the auth server should be able to read that path and use that issuer header of the path to identify the issuer. Otherwise, you're in this situation. So by default, up until auth server 1.3, the only architecture supported, the only configuration supported was the one you see on the left here, which is single tenant, which means that each auth server is just one issuer of tokens, and it's identified uniquely by the entire base URL of that auth server. So if you want to have two different issuers of tokens, you have to have two Spring Boot instances that are auth servers and connect your clients to those two separate ones. Now, by implementing that part of the OIDC spec, what is supported is that you can use the issuer ID in the URL address pointing to the auth server, and the auth server will take that and it can host two different issuers and keep them separate. So in fact, I think maybe we can demo this part. Let's see. So I'm just going to start an auth server. And where are my slides? So if I hit this URL, so this was the spec, right? The spec is saying that this is the URL that should be resolved. So if we hit this one that doesn't have, you can see here that it just takes that issuer address as we gave it without an issuer in the path, and it'll return. So the client will hit that endpoint and it'll return all of this information based on that URL. Whereas if we do include the issuer here in the path and we hit that URL, then the auth server should be able to then see here, it knows how to process that issuer. So it's basically like another filter that's acting in order to support this feature that captures that, analyzes the path, and then creates all of these redirect addresses appropriately. So it's the ability to handle that, basically. So to enable that, so that feature, while it is supported in Spring Authorization Server 1.3, it's not enabled by default. You have to manually enable it. So you can do that either in the code, or if you are also using Spring Boot 3.3.2, then there is a Spring Boot property in order to enable that. So what's not in the spec, so in the spec it says how to handle the URL with a path. What's not in the spec is, as I mentioned, the auth server has a database. It's either, if you don't actually connect it to a physical database and it's just using an in-memory map, or if you connect it to a database via JDBC, then it has a schema that it creates and it stores the data in the database. But either way, the auth server only stores all the data for all issuers, all of the clients, all of the tokens, all of the grants in the single schema in the single database. What's not in the OIDC spec is any instruction about how to isolate that data between issuers, et cetera, right? So that is really up to you. It's an implementation that it's not necessarily appropriate to put it in the framework. It's just sort of a case-by-case basis, depending on what you want to use, et cetera. Because of that, the feature is disabled by default, basically. So both for data isolation, but also because it's a single schema and the tables are kind of flat, if you wanted really high performance, you might also want to change the schema. So that is also up to you. So while this feature, while multi-tenancy is supported at the path level, oops. The implementation is up to you. So what the Spring team has done is that they wrote a how-to guide as an example of one way that you could achieve the data isolation across two JDBC databases. So that's the link for the how-to guide. I'll show you, just keeping an eye on the time. And I want to credit, this is Joe Granja's work. And that's the link to the demo that he has. And so I'll just walk a little bit through how he did this in this example. So basically there are 4 classes within auth server that will persist data: the registered clients, the authorization service, the consents, and then the key store. The key store, often you will probably want to store that in some kind of maybe vault or something like that. So you don't necessarily want to store that in that same database, right? But these are the 4 things that persist data. So in the example that he created, first he creates an in-memory map where the first level is the issuer, the key is the issuer. So in this case, he had 2 different issuers. And so then within each of those, he has another map that has the name of the class, which would be one of those 4. And then the value is the created object instance for that. So that's how he's keeping separate the components for each of those 2 issuers. So this is, so there's a class that, so in his example application, there's a class that implements that in-memory map. And then he has another class that's generating two different data sources. In this demo, he uses H2, but you can use anything or any JDBC implementation. And then for each of the four classes that persist data, he then has to do a customization so that that class takes as input both that in-memory map and also the JDBC, the bean for the right data source. And like I said, the JWK, the key store one, is not actually storing data. So out of this example, we expect these three tables to store data. So I can show you how that works. So we have here, I'm going to start this in debug mode just to have a breakpoint in there, the auth server. Is that right? Yes, okay. And then we're going to start the client application, and we'll start the resource. And are they started? Okay, so we're going to log in. And this is just using, the auth server as an IDP. So we consent to the profile. This is the part where we're logging in, and it says, can I share your profile information? And then we hit this breakpoint. Okay, so what I want to pull out of here is the access token. And then we'll look at it. So we'll go to JWTIO. So you can see that it's only for client one, right? So we're logging in by default. It's configured to log in using client one, but it's not mixing the two. So that's one thing to sort of notice there. And then let's go ahead and let this go. And so then we're in. So then what I'm going to do is hit authorization using issuer 2 now. And so it's asking me, I'll do both. So it's asking me now for authorization to access these specific resources. So I'm going to submit that consent again back here. So we're going to copy this token. And I'll show you that this one is now client 2 specifically only. It keeps that user information, but it's isolating the user 2. So let's finish that up. And then let's do the authorization for 1. Is that? Oh, it didn't. Did I already consent to that? Well, okay, there we go. For client 1. So then it asks me to consent to client 1. And again, here we'll see. Let me grab this value. I'll let it go. Go back up here. And again, we should expect to see now the client 1 read and write. So if we look at this through the H2 console, okay, so we can go into the issuer 1 database, for example, and we'll look at under authorized clients, for example. So we see that as far as the authorized client, it's only client 1 in database 1. Can you see that? So user 1 was authorized in client 1. Also, for the only client registered is client 1, right? So it's keeping the data also separated in the database, right? And also it's got the authorizations also kept separate. Only for this is only for client 1. Message read and write for user 1. I guess that's farther to the right. But it does keep them separate, basically. And then if we were to log out of here, and do client database 2, we would see something similar, but just for database 2. So we could look at the authorizations, for example, and we'll see that it's different because it did the login, the OIDC login through client 1, and it only did the grant for client 2. So kind of the same thing, right? So that's an example. Here's the grants for client 2, and then just the registered client for client 2. So data isolation at the JDBC level. So that's one feature. Where's my presentation? Okay. So then the other feature is token exchange. Okay. So so here the problem statement. I'll show you 2 examples of architecture, but this is a fan out architecture, meaning that from the same OAuth client, we're fanning out to multiple resource providers. So if you have you've authenticated and then you've granted the authorities for resource server 1, if the resource server 1, if you then want to call resource server 2, how do you manage that, right? Do you go back and ask the user for the new grants, or do you get them all up front, or what are your options for then calling another resource that has different scopes? So one option is in fact having a single reusable token where upfront you just ask for all of the permissions and then you're just using that same thing. So let me think about, let's see, maybe we do all this demo upfront as we're going. So I'm going to take this away. Okay, so let's start the auth server. Oh, hold on a second. Let's do let's kill all the other processes. Okay. Okay, now we can start the, one second, what's happening? Okay, so we started the auth server. Then we'll start the gateway. So here we have it's not just an OAuth client, we're combining it with a gateway. Why is this so slow? What's happening here? Okay, I don't know, my computer's acting very slow. Gateway and Cash card client. Okay, so we have basically cash card and purchase are the 2 resources we're trying to reach. The gateway is our OAuth client. You know what? Maybe it's this. All right, let's try that. See if this reacts better. This is so weird. Okay. All right. Okay, so we have everything started up. Sorry, I'm going to start them up because they're not showing all the ports, right? So let's just do this again. I appreciate your patience. Okay, let's start the auth server. And we'll start the gateway. Okay. That looks better. Okay. So now, okay, so we'll send a request to the gateway, right? Because that's fronting our applications. And here we're going to log in as, so this is in this demo, Steve has customized the login page to look a little bit prettier. It's not that default SpringOne. So I think it's Cora password. So we log in and we submit the profile. And then if I want to go to cash cards, what's happening? Hold on. Oh, I know what's happening, I think. Sorry, let's see. Exchange. Let's try that one more time. All right, let's try that again. We'll start the auth server first, then we'll start the gateway. And then we'll start these two. Okay, everything's running. All right, we'll try that again. Okay. Okay, this is okay. Okay, so this is that first scenario, right? Where we're just going to use the same token for everything, for all of the different resources. So it just asks us from the beginning. This is the profile one for the OIDC part, and then the cache card, the two cache card permissions, and the purchase permission. So if we submit this consent, then we can talk to cache card without a problem. It's not going to ask us again. It should work. I don't know why it's not working. There's that one. Yeah, cache cards should work. There we go. Okay, cache cards. And so we can access both resources, and we haven't had to ask anybody. And if we were to look at that, I took out the breakpoint, but if we were to look at that token has the profile and it has all permissions for everything, which, you know, if you want that user experience, if you want to get all that out of the way at the beginning, then it's not an invalid way to approach. But it could feel a little bit invasive to the user depending on your situation. And also you have this token that's larger than it needs to be and also has more permissions that you need to have in it. And so you might be breaking the principle of least privilege, right? So there's a few disadvantages to this one. So another option is what you often see with your applications where they ask you, can I access your contacts? And when you want to share a photo, can I access your photos? Can I share this photo? So they really ask you on demand. And so that experience, okay, hopefully this goes right on the first try. So we'll stop all of these. If you want to do these demos, these are all different commits within the same application. So we'll stop that. We'll start this back up again. Start that. Start the gateway. Start cache card. Start purchase. And so now when we try this again, oops. So now it's asking for the OIDC stuff, and then it didn't ask me for anything else, right? And it's only at the moment that I want to use the cache cards application that it asks me, okay, now, do you grant this permission? And then it issues a token that is strictly for this. It only has these two grants in it. And then when I say, now I want to look at my cache card, at my purchases, it says, okay, do you consent the purchase read permission? And so I submit consent and it lets me go in. And so it's actually each time generated. So you've had the client and the auth server interaction, each time a totally separate transaction generating two separate tokens. Also not bad. Then you're really respecting the principle of least privilege. But do you want that user experience, right? Maybe, maybe not. So the third scenario, which is the thing that's new in auth server 1.3, is that sometimes, and especially because when you're talking about Spring Authorization Server, you're talking about internal permissions, right? You're not talking about Google or GitHub or Facebook. So often it doesn't make sense to even prompt the user for these permissions that are really more relevant to your internal architecture. And often these experiences to the user are kind of jarring because they're like, I don't even know what I'm granting permission to. What are you even asking me? I don't want to use this application, right? So you want some of these to be based on an initial trust and then just have that same initial token be relayed between these resources. So you want the best of both worlds, right? You want to not ask the user, but also for different tokens to be used so that each token for each resource server only has those permissions, right? So you have principle of least privilege respected, but you're also shielding the user from a bad user experience. And so that's what this token relay, that's what this token exchange does. The feature is called token exchange, where the auth server is still granting tokens as needed, but that the grant is implicit based on the initial OIDC grant. So I'll show that one to you. So we'll stop all of these. And we'll do GC3. And back to services. And for this, I'll add this breakpoint in here. Okay, so we'll start the auth server back up in debug mode. Oh, sorry, not the auth server. This is This is the gateway. Sorry. Yeah, this is so token exchange is a filter on the gateway. It's triggered by a filter on the gateway. So we'll start the gateway in debug mode to hit the breakpoint. And then we'll start these two. Okay, so and sometimes the ports show up and sometimes they don't. I don't know. Okay, so we'll try this again. All right, so we are going to log in. Of course, it asks us for that initial grant, and everything else will be inferred based on the fact that I've consented here. So I'm in now. And no, so far, we haven't hit the breakpoint, right? So no actual access token has been issued yet. So I'm going to try to hit cash cards. And here we're hitting the breakpoint. So it's issuing a token, but I wasn't asked if I grant permission, right? So here we can look at the access token and go to, but we can see that it's specifically just cash card permissions for this cash card client. The audience is what the resource uses to verify that it was this request is intended for it, that the token's intended for it, and it's maintained the profile, the knowledge of who the principal is from that OIDC, right? So it's combined those, even though it never asked me. So if we pass this, we'll see that the result is that it just shows me the cash cards. Same thing if I try to hit the purchases, we hit the breakpoint. We can copy this value and look at the token. And we'll see again, it's maintained the principal information, but it's intended for purchase client only, and it only has a purchase read permission in it. And if we pass that breakpoint, then we're shown the cash cards, and I was never asked, right? So it's kind of the best of both worlds for internal applications. So that's that token exchange feature that's new. And then here's, that's not the only architecture you'll see it in. You could also see it in this kind of architecture. In this case, what's different is that the resource server 2 is not even connected to that same OAuth client, right? So in this case, you might wonder, well, if the OAuth client has obtained the grants and the tokens to talk to resource server 1, and then resource server 1 in some kind of layered architecture, or it could be, it doesn't have to be a layered architecture. It could be that resource server 1 is owned by one development team, or maybe it's deployed in one sort of a physical deployment that's in a different access point. Whatever the reason is, how does resource server then get the ability to talk? You have an API that wants to talk to another API. So in that case, what really happens is that your resource server 1 itself has to be an OAuth client. So you would also add the client library to it and then connect it to the auth server. And so then resource server 1 can go to the auth server and do that token exchange, saying, I have the OIDC token. I want to exchange that for the right token to talk to this other resource. It still respects that sort of inferred trust. And so it gives it the ability, but each one is still using a different token that's specific for that audience and that has specific grants. So that's another case where you might see that. So, so we saw Steve's demo already. Okay, so the last thing I wanted to mention, so that's all the open source solution. The commercial team at Tanzu has sort of made a packaging of auth server that has a nice feature for development and testing purposes. It's called Tanzu Local Authorization Server. And as it says, it helps with running a real authorization server locally without having to configure something like Okta or Keycloak or integrate with something external. Just very easy, very lightweight to use if you do need to test your apps against something with OAuth. So again, just it's a jar file. It's that same auth server, but it's packaged as a jar file with some default configuration in it. So it has like a default user, can log in as user password, and then it has a configuration file sample that you can look at if you want to change. It also has a default client, the client ID and secret, what the client uses to validate itself against the auth server to communicate with it. So that all of that is sort of pre-configured as an easy sample. And of course, you can always pull out the default configuration and change it and supply your own YAML file, add clients, add permissions, add users, whatever you need. So it's really useful for just your own local development testing. It's useful in your CI toolchain as well, right? So you don't, it's just a little bit easier to use. It's not only for Spring clients. You can use it with any client. And for testing, it's compatible both with test containers and with Spring Boot test jars. Are you familiar with Spring Boot test jars? Or test containers? Are people familiar with test containers? Okay. So test containers was created by it was an open source project that was basically based on a JUnit rule. Initially, like 10 years ago when this idea started, somebody suggested that a JUnit rule could actually spin up a Docker container for you as that external system. So if you needed to test against a database for your integration tests, then this JUnit rule would spin up that Docker container for you and automatically generate sort of a random port, and then you would have that back in your code, and then you can connect and do your integration tests. The company called Atomic Jar made a commercial version of that. They were recently bought by Docker, but it's obviously test containers itself is open source. So what happens is you can take that Spring Authorization jar file and have that started within a Docker container that just has a Java runtime, and test containers will automatically inject that port back into your application. So you can start auth server on a random port, and then Spring Boot test jars is basically just a way to execute a job, like to start a Java process. It's a Commons exec basically implementation. So also from within your tests, you can have your test code spin up authorization server as a Spring Boot application separately, and then you talk to it, and then when your process shuts down, of course, it owns the other process, so that process also shuts down. So the advantage of Spring Boot test jars over test containers is that there's no dependency on Docker, and because of that, it's also a little bit faster to start. But either one of them will work. So, and this is, of course, a commercial release. So the way that it works is that in your client application, you simply add this configuration. So you tell it to talk to auth server started at port 9000, and you just use the default ID and password for the client to be able to talk to the auth server, and these default scopes for that initial OIDC portion. And you can start it just Java jar with the jar file name. We'll start it standalone. If you do print sample config, it spits out the YAML file that you can use to configure the behavior. You can change the port, users, claims, etc. There's also a demo available online. And I have a slide of all the links at the end. And so, yeah, that's really it. So this is the different references if you want to kind of keep learning about this stuff. Both of the demos that I used for this presentation, the how-to guide on that multi-tenancy for the data isolation, some more general resources. There's like a intro to Spring Security course that we have on Spring Academy. And then the last two links are specific to that commercial release, both the documentation and the demo that's available online. And the last thing I'll say is that since you're interested in security, I highly recommend coming back. We're going to have Rob Winch and Josh Long at 10:50 a.m. talking about passkeys. And so ask them all your hard questions. And that's it. Thank you for coming. I hope that was useful. Cool. Any questions? Yeah.
So when you say auth server, right, and you configure the authentications in the database, does it support other systems like NTF and anything else inbuilt?
Yeah, you can use. So the question is, does auth server work with other kinds of IDPs? Yeah, yes, LDAP, Okta, yeah, all of those. Yeah, it can be an abstraction layer to other systems.
Does it provide support to connect to those things to actual IDPs?
As libraries, I actually don't know exactly what the configuration is for it, but I think it was intended to act as an abstraction layer. So I'm sorry, I don't know off the top of my head how to configure it, but yeah, it's definitely it's built for that use case also. So I don't think it's super complicated. Yeah.
Thank you.
You're welcome. Cool. Well, I'll be around. I'm here also all day. I'll be introducing the speakers later. So at any point, you can come up to me. I have a modulith talk tomorrow if you guys want to come to that. And up next, we're going to have, I guess, at 9:55, in about 15 minutes, we're going to have Oleg Zurikowski talking about streaming, sort of the state of the union, state of the state, the latest and greatest on streaming with String. So, yeah. Thank you.